Here's the dial spindle after it's been cut to length. Notice that the end has been squared off and the end has been beveled very slightly to make it easier to install back into the drive cam. And now I'll thread it back through the front of the safe into the drive cam again. I thread the dial in until, again, the top surface of the dial is pretty much flush with the top surface, raised surface of the dial ring. And then I place 0 under the opening index. Holding the dial at 0, I'm going to manually position the drive cam so that this gate or cutout in the edge of the drive cam is underneath the lever nose so that the lever can move up and down slightly. In this position, I can see that the spline keyway in the spindle is nearly lined up with this spline keyway in the drive cam, which tells me that my spline key needs to go in this way. And now I can take the small spline key screw that was provided in my accessory kit, and I can install that into the tapped hole in the drive cam, and that holds the spline key securely in place. So now it will move with the rotation of the dial. Remember that our dial ring screws are still loose, and so we can move it into what feels like the best alignment between the dial and the ring. We can also position it so that the opening index is at top dead center, and I check the relative heights on this top surface of the dial and the top surface of this raised ridge around the edge of the dial ring to get these surfaces as even as possible. Once I have it where I think it belongs, I'll take some masking tape and, being careful not to move the dial ring, I'll use as much tape as I think is necessary and tape it into position so that I'll be able to remove the dial and then tighten the dial ring screws. To remove the dial, we first need to remove the spline key. We'll loosen and remove the small screw that holds it to the drive cam. It's a little tiny screw. We want to be careful not to lose that. To carefully back the spline key out, we'll take the longer of the 2 lock cover screws and we'll thread it into the center threaded hole in the drive cam. And making sure that the spline key will not come out into the underside of the lever, as we tighten that screw, it backs the spline key out of its connection and it comes out with no damage. And this spline key is absolutely reusable. Being very careful not to move the dial ring, hold the drive cam with one hand and unthread the spindle from the drive cam with the other. Now again, being very careful not to move the dial ring, remove the screws one at a time. Put a single drop of the Loctite 242 thread locker on the end of the screw. Reinstall it, and this time tighten it. Now our dial ring is installed and it's as closely aligned as we can get it. Let's back up a couple steps and look at an alternate way to size your spindle length. You remember we measured our door thickness early on in the installation, and it came out to 1.180 inches. If we simply add 7/10 of an inch, or 0.7 inch, to that dimension, we come up with a measurement of 1.88 inches, and I can measure that from the base of my spindle up to the bottom of where my caliper is set now at 1.88 inches. That's where I can mark the spindle and cut it. So if you measure the door thickness, this is actually a much easier, more efficient way to get to the correct spindle length. Let me show you a dial ring alignment tool that you can make yourself. Here's a drive cam from a typical commercial grade 6730 model S&G lock. You'll notice it's machined out of brass. It has this little drive pin on the underside. In order to use this as an alignment tool, we'll have to drill out that drive pin so that we don't have a projection on the underside of the drive cam. I've got this drive cam threaded onto a scrap piece of 5/16 by 40 thread per inch spindle, and this will also be part of our makeshift alignment tool. And even though it's homemade, it works extremely well. There's a swivel bearing in the center of the dial ring, and the hole through the center of that swivel bearing is the same size, well, within a few thousandths of an inch, of the diameter of the neck on our alignment tool drive cam, the one in which we've drilled out the drive pin. So we insert the drive cam into the center of the dial ring, and then from inside the safe, we stabilize the LOX drive cam, and we thread our tool spindle into the drive cam. And then we can rotate the drive cam independently of the spindle so that it secures the dial ring in place. Once we've tightened this drive cam to the point where it's holding the dial ring snugly against the front of the safe, we can align it, the dial ring, straight up and down, and we know that we have as close to perfect alignment between the center of the dial ring bearing and the center of the drive cam as is humanly possible. Now we can install and tighten our dial ring screws. It'll be aligned and installed. No matter which method we use to align the dial ring, before we install the attaching screws, we need to use a drop of Loctite 242 thread locker to make sure that those screws stay in place. And since I have my alignment tool in place, I can tighten those screws when I first put them in. Once the dial is installed, we can thread our alignment tool spindle out of the drive cam, and the tool comes out complete.